Hello and welcome to Edu Sathi's lecture on probability. Probability is a very interesting topic, and also it has a lot of concepts which you want to keep in mind before solving questions in examinations. Mostly people get wrong answers in this topic because either your fundamentals are not clear or just some silly mistakes. So in this lecture I will cover all the concepts on probability, followed by video number 2 on probability, in which I would solve some practice question based on the concept discussed in this first video. What is probability? The measure of the likeliness that an event will occur is called probability. It is quantified as a number between 0 and 1, where 0 indicates an impossible event and 1 indicates a certainty. For example, let's take this impossible event 0. Now, if I tell you that what is the probability of getting a 7 on a roll of a dice, what is the probability? Obviously, it is 0 because the dice has numbers only from 1 to 6. So, this is a kind of a improbable event or impossible event, an event which cannot happen. What is an event which is certain? A certain event would be something like getting a head or a tail in a toss of a coin. I am sure that one of the two will definitely occur. So this is a certain event. If I ask you what is the probability of getting either a head or a tail, I am sure that one of them will occur. So this is a probability of one, a certain event. What is an even chance? If I say what is the probability of a head when a coin is tossed once, so this is equal to 0.5, and the probability that a tail will occur, this is also 0.5. So such events are called equally probable events, or they have an even chance of occurring. Okay, what is unlikely? If the probability is less than 0.5. For example, if I ask you what is the probability that the number 1 will occur in a throw of a dice, so what is the probability? The probability is 1 by 6. So this is an unlikely event. And likely event is when the probability is greater than 0.5. Okay, we'll have more clarity as we move in the slides forward. Definition. The definition of probability is the number of favorable outcomes by the total number of outcomes. For example, let's take a practice question. What is the probability that in a toss of coin, head comes up? Okay, so now I know that if I toss a coin, either there will be a head or there will be a tail. So what are the total number of outcomes? The total number of outcomes are 2, either a head or a tail. What is my favorable outcome here? Favorable outcome, it is that head comes up. So head is my favorable outcome, which is in numbers just 1. So what is the probability? Probability is 1, which is the number of favorable outcomes, divided by 2, which is the total number of outcomes. So probability is 1 by 2 or 0.5, as mentioned here. Now probability of E bar or E naught, as we say, why do we put this dash? P, and here is E with a bar on top. This means that probability of not E. Not E as in the event not happening. In this case it would be that the head does not turn up. So if head does not turn up, it means, in other words, the probability of a tail, which is equal to 1 minus probability of E. So I have 1 minus, what is probability of E? 1 by 2. So I have probability of E naught or not E as 1 by 2. I hope this is clear. If not, we'll do some practice questions in the next slide, and I'm sure that you'll be clear with the first part, which is definition of probability. So let's do some practice questions. What is the probability of getting at least 1/6 in a single throw of 3 unbiased dices. Unbiased dices means all the dices have numbers from 1 to 6. A normal dice which we use in a game of a Ludo or snakes and ladders, that is a unbiased dice. So I throw 3 dices and I need to have at least 1/6. So probability E here is getting at least 1/6. Okay, 1 I can write like this, 1/6. What will be probability E naught getting no 6? Okay, so we know that probability of E plus probability of E naught is equal to 1. This is obvious that this is a probability that the event will occur. This is the probability that event will not occur. Obviously, either it will occur or it will not occur. So the combined probability is 1. Now, it is easier to find out probability of E naught here. That is getting no 6 in 3 dices. So let me draw 3 dashes here as we did in permutations and combinations. So these are the 3 dices. Now any number from 1 to 6 can occur in this place because I roll a dice, but I am finding out the probability that 6 cannot occur, getting no 6. So 6 cannot come here. So the only numbers that can come in this place is 1, 2, 3, 4 and 5. These are the only numbers that can occur. Similarly, in this space also I can have these 5 numbers, and in this space also I can just have 5 numbers. So what are my favorable cases here for getting no 6 for probability of E naught? What are my favorable cases? 5 into 5 into 5. Okay, so this is the dice number 1, this is dice number 2, and this is the dice number 3. So these are my cases. Any combination is possible. Now we have to divide by the total number of cases as in the definition of probability. So what are the total number of cases? Total number of cases are 6 into 6 into 6, because when we count the total number of cases, I can have this space filled up by 6 spaces. 6 can also occur for total number of spaces. Similarly, for this space also 6 can occur, and for this space also I can have 6. So let us find out the probability of E. What was E? Getting at least 1/6. So probability of E plus probability of E naught is this, 125 by 6 cube is 216 is equal to 1. So what is the probability of event that at least 1/6 occurs? It is 1 minus 125 by 216. You can solve this to get the final answer. So this comes out to be 91 by 216. This is my final answer. The second practice question here. What is the probability of getting at least 2 heads when a coin is tossed 3 times? Okay. So let us form the total number of cases first. A coin is tossed 3 times. So either I can have head all the times, I can have head, head and head, or I can have 2 heads and a tail. Now this tail can occur at the last, at the third toss, at the second toss, or at the first toss. So we've already listed on 4 cases. Now I can also have 2 tails and 1 head. So I can have tail, tail and head. Then I can have tail, head and tail. And similarly I can have head, tail and tail. and also I can have all three tails. So let's count the total number of cases. I have 1, 2, 3, 4, 5, 6, 7 and 8. So probability E here is something divided by 8. These are the total number of events that can happen. What is probability of E? Getting at least 2 heads. So let's count the number of cases where I get 2 heads. This is one case, I get all 3 heads. So this satisfies this case. This case is okay, I have 2 heads and a tail. This case is also okay, I have 2 heads and a tail. And this case is also okay, I have 2 heads and a tail. So the number of favorable cases here are 4. So my probability is 1 by 2. I hope now that the definition of probability is clear. We just need to find out the number of favorable cases, which in this case was 4, and the number of total cases. Let's move on. Here are some more definitions. Sometimes in questions it is mentioned what are odds in favor of an event or what are odds against an event. What are odds in favor? The number of favorable outcomes. This is the same as we calculated while we discussed the definition of probability. The favorable outcomes is the same. The number of unfavorable outcomes are given as total outcomes, which we also calculated, minus the favorable outcomes. So these are the unfavorable outcomes. Similarly, odds against, we'll have unfavorable cases in the numerator and favorable cases in the denominator. Just the inverse of this, inverse of odds in favor. Okay, so we can calculate the number of favorable cases and find out the unfavorable cases using this formula here as well. Let us do a practice question. What are the odds in favor of getting an even number on a single roll of a dice? So I want to know what are odds in favor. Odds in favor are given as number of favorable outcomes. So in a dice, what are the numbers that can come up? 1, 2, 3, 4, 5 or 6. I want an even number as mentioned in the question. So even number is 2, 4 and 6. These are the 3 even numbers. So my number of favorable cases is 3. What are my number of unfavorable cases? The odd numbers 1, 3 and 5, which are also 3. Or I can find it out using the total number of cases is 6 and the number of favorable cases are 3. So 6 minus 3, which is again equal to 3. So what are the odds in favor of getting an even number on a single roll of dice? It is 1:1. This is my answer. Let's do some more practice questions on this definition in the next slide. There are 3 people X, Y and Z who are selling tickets of a lottery. The odds against their selling tickets are 4:1, 3:2 and 4:1 respectively. What is the probability that at least one of them could sell all their tickets? Okay, so first let me write down the question. The odds against, in the question it is given against, X are 4:1. So if you look carefully, these are the number of unfavorable cases, as we have mentioned odds against, and these are the number of favorable cases. So what are the total number of cases for X? I can easily write 4 plus 1 is equal to 5 are the total number of cases. So if I have to write P of X, here P of X denotes that X can sell all his tickets. What is the probability? Number of favorable cases by total number of cases, which will come out to be 1 divided by 5. I hope this is clear. What will be Px bar then? Now Px bar would be that X cannot sell all his tickets. This means that X cannot sell all his tickets. This is P x bar. This would be what? 1 minus P of x, 1 minus probability that he sells all his tickets, which is 1 minus 1 by 5, or in other words is 4 by 5. Similarly, for y, I have given odds against R 3:2. So these are the number of favorable cases, and these are the number of unfavorable cases. So what are my total number of cases? It is favorable plus unfavorable, which is 3 plus 2, which is again 5. So what is P of y? P of y is the probability that y can sell all his tickets. This would be number of favorable cases, which are 2, divided by the total number of cases, which are 5. Similarly, P of y bar would be what? 1 minus 2 by 5. Here y bar is what? That y cannot sell all his tickets. So this is equal to 3 by 5. Similarly, when you calculate P of z, this will come out to be 1 by 5, as it exactly the same case as P of x. So I can write straight away, and P of z bar would be 4 by 5. So I've put all the information we discussed in the previous slide in a more ordered form. P of x means x sells all his tickets. The probability is 1 by 5. P of x bar is 4 by 5, means that x cannot sell all his tickets. Similarly, we have P of y and P of y bar, P of z and P of z bar. Now let us look at the cases. What are the different cases that are possible? X, y and z here means that all three of them are able to sell all their tickets. In this case, I have an x bar, which means that y and z sell all their tickets, whereas x is not able to sell all his tickets. In this case, y is not able to sell all his tickets. In this case, z is not able to sell all his tickets. Then we move on to the case when two of them are not able to sell all their tickets. So I have x bar and y bar, which means that x and y are not able to sell all their tickets. Here, y bar and z bar means y and z are not able to sell all their tickets, and x bar and z bar means x and z are not able to sell all their tickets. And in this last case, none of them sell all their tickets. So let's look at the probability. X, y and z all sell. So I have 1 by 5 multiplied by 2 by 5 multiplied by 1 by 5. This is P of x, this is P of y, and this is P of z. So this gives me 2 divided by 125. Similarly, P of x bar is 4 by 5, and then P of y is 2 by 5, P of z is 1 by 5. So this is equal to 8 by 125. Let's look at this case. X sells all his tickets, so 1 by 5. Y does not sell, so I have 3 by 5. And here again, I have 1 by 5. So this is equal to 3 divided by 125. In this case, X sells all his tickets, Y sells all his tickets, so this is 2 by 5. And Z does not sell all his tickets, so it is 4 by 5. So this gives me 8 by 125. Here x and y don't sell all the tickets, so I'll have 4 by 5 multiplied by 3 by 5 multiplied by 1 by 5, as z sells all his tickets. So this gives me 12 by 125. Similarly, here x sells all his tickets, y is unable to sell, so I have 3 by 5, and z is not able to sell, so I have 4 by 5. So this again gives me 12 by 125. Here y is able to sell all his tickets, whereas x and z do not sell, so P of y is going to be 2 by 5, and again here I have 4 by 5. So this gives me 32 by 125. The last case here, none of them sell all the tickets, so I have 4 by 5 into 3 by 5 into again 4 by 5. So this gives me 48 divided by 125. Now, what is asked in the question here? What is the probability that at least one of cell could sell all their tickets? The answer is either I add all these 7 cases here, because in these 7 cases, at least one of them is selling all the tickets. So what I can do is I can add this 2 plus 8, 10, 13, 13 plus 8 is 21, plus 12 is 33, plus 12 is 45, 45 plus 32, we can just calculate quickly. 45 plus 32 gives me 77. So the answer is 77 by 125. This is a longer method. A shorter method would be, I know that all these cases will add up to a probability of 1. So what I can do is, from this probability of 1, I can simply subtract the case when none of them is able to sell all their tickets. So 1 minus 48 by 125. So this will give me 125 minus 48 divided by 125. This again gives me the same answer. 15 minus 8 is 7. 11 minus 4 again is 7. So this gives me 77 by 125 as the answer. So in this kind of questions, whenever you are asked that at least one of them is able to do one thing, you should always take the total probability 1 and subtract the probability when none of them is able to do that thing. Okay, so here the thing was selling tickets, so I did 1 minus this probability that none of them was able to sell all their tickets. So let's move on to this next concept of mutually exclusive events. Two events are said to be mutually exclusive if both of them cannot happen simultaneously. For example, in a roll of dice, getting an even number and getting an odd number. So A and B cannot happen together for sure. I cannot have an even number as well as an odd number. So A and B are mutually exclusive events. Let's take A and C. A and C is getting an even number and getting a multiple of 4. Now 4 is such a number which is even as well as a multiple of 4, because 4 into 1 is 4. So these two events A and C are not mutually exclusive, as they can happen together. Here A and B could not happen together, so they are mutually exclusive. Let's take B and C. Getting an odd number and getting a multiple of 4. Also these two events cannot happen together. So B and C are also mutually exclusive. From a pack of cards, getting a spade and getting a red suit. Spade is black in color and red suit, as it's mentioned, is red. So these both cannot happen together. So A and B here are mutually exclusive. Let's check B and C. Getting a red suit and getting a king. I can have a red king, I can have a king of hearts, also I can have a king of diamonds. So in this both these cases I have a red suit and a king. So these can occur together, so these are not mutually exclusive. Similarly, getting a spade and getting a king, I have a king of spades. Sorry for this wrong diagram. So I have a king of spades. So these two occur together, or these two can occur together, A and C. So again A and C are not mutually exclusive. Let's try out a question on this. What is the probability that a 2-digit number selected at random will be a multiple of 3 and not a multiple of 5? So let's calculate the total number of 2-digit numbers. The highest number is 99 and the smallest number is 10. So the number of 2-digit numbers is 99 minus 10, that is 89, plus 1, as both of them have to be included. So I have 90 2-digit numbers. Also, if you calculate like this, like we did in PNC, so I have two spaces. This units place can be filled up in 10 ways. I can have any digit from 0 till 9, and this tens place can only be filled in 9 ways, from 1 to 9. I cannot have a 0 here, because if I have a 0 here, it will become a 1-digit number. So I have 9 ways to fill this place and 10 ways to fill this place. So I have 90 2-digit numbers. Now out of these 92-digit numbers, if I divide 90 by 3, I have 30 numbers which are divisible by 3. And we want the number should not be a multiple of 5. So in this 30 numbers, I have numbers like 15 or numbers like 30, even 90. Now these numbers are also multiples of 5. So from these 30 numbers, I basically have to remove the numbers which are a multiple of 3 as well as a multiple of 5. So this means a multiple of 15. So what I'll do is, out of these 92-digit numbers, I divided by 15. I have 6 numbers. 90 divided by 15 is 6, which are a multiple of 15. So 30 minus 6 is equal to 24 are such numbers which are multiple of 3 and not a multiple of 5. So what is my probability here? The probability is 24, which are the number of favorable cases, divided by 90, which are the total number of cases. So this is my probability here. If you want to simplify, you can add 6 4s are 24 and 6 15s are 90. So 4 by 15 is my probability. Let's move on to the next concept, the addition law of probability. In case of mutually exclusive events, now we all know what are mutually exclusive events, which cannot happen together. So we did this in the last slide, cannot happen, sorry. So these cannot happen together. The probability that at least one of them occurs is given by simple addition of probabilities. So that means P of E or P of F is simply P of E plus P of F. For non-exclusive events, we have P of E plus P of F minus P of E and F. In the case of mutually exclusive events, this P of E and F is actually equal to 0. So from a pack of cards, let's take A and B, getting a spade and getting a red suit. So let E be an event of getting a spade and F be an event of getting a red suit. So if I have to calculate P of E or F, I will simply do P of E plus P of F here. So this P of E would be probability of getting a spade. What is the probability of getting a spade? I have 13 cards of spade out of a total of 52 cards. So 13 by 52, and probability of getting a red suit is 26 divided by 52, because red I have hearts as well as diamonds. So the total probability is 39 divided by 52. Let's take another case. Probability of getting a spade and getting a king. So these are not mutually exclusive because I have a king of spades. So these two can occur together. So here if I define E as the probability of getting a spade and F as the probability of getting a king, here P of E or P F would be P of E plus P of F minus P of E intersection F. This is the formula written here. So here P of E is what? P of E is getting a spade. So that is 13 by 52. What is the probability of getting a king? I have 4 kings in a pack of cards. So I have 4 divided by 52 minus P of E intersection F. It means getting a spade and a king. There is just one card which is the king of spades. So minus 1 by 52. So this gives me 16 by 52 as the answer. So remember this formula. You can simply remember this, and in case they are mutually exclusive events, then P of E and F would definitely be 0 because they cannot occur together. So you don't need to actually remember this formula, just remember this one and put 0 in case of P of E and F if E and F are mutually exclusive. Let's try out a question on this. A number is selected at random from first 30 natural numbers. What is the chance that it is a multiple of either 3 or 13? So I define P of E as a multiple, I write M for multiple of 3, P of F as M13, so multiple of 13. Now what would be P of E and F? E and F, or this is what we call P of E intersection F, a multiple of 3 and 13, which would make a multiple of 39, because the lowest common multiple for 3 and 13 is 39. So I have to find of P of E or P of F. By definition, this is P of E plus P of F minus P of E intersection F. Okay, so P of E is a multiple of 3. What is the probability for this? I have first 30 natural numbers. So I have numbers from 1 to 30. How many multiples of 3? 30 by 3, which is just 10. How many multiples of 13? I will have 30 divided by 13. This would be 2 point something, so just 2 multiples. I will have only 13 and 26. Multiples of 39, since I have only first 30 natural numbers, so here this is 0. 39 is the first number which is common to both. So what is the answer here? I'll have 10 plus 2 minus 0. Actually, this is not 10, this is 10 by 30. These are the number of favorable cases. These are the total number of cases. Similarly here, P of F is 2 divided by 30. These are the number of favorable cases. These are the total number of cases. So my answer is 10 by 30 plus 2 by 30 minus 0 by 30. This is 0. So I have 12 by 30 or 2 by 5 as the answer. Let's move on to the next concept, which is independence of events. Two events are independent of each other if the occurrence of one has no effect on the occurrence of other. For example, in a darts game, the target is missed for the first time. Imagine yourself playing a dart game. So you miss the target the first time, and the target is missed for the second time. Both of them have no relation. If you miss the first time, it is not for sure that you will miss the second time, and it is also not for sure that you will hit the second time. So these two events are independent of each other. In drawing a card from a pack of 52 cards, the first card is drawn is a spade. The second card is a club and is drawn without replacing the first card. And the C event is the second card is a club and is drawn after replacing the first card. So here, if I take this event A and event C, these are independent of each other because you remove one card and it turns out to be a spade. You replace that card in the pack of 52 cards. So you replace that card and then again you draw a card. So it comes out to be a club. Now these two have no relation to each other and will not affect their probability. The probability of a spade coming in the first go would be 13 by 52. And since now you've replaced this card, the probability of club is also 13 by 52. So it is not altering the probability of a club coming after a spade. So A and C are independent events. The multiplication law of probability holds if E and F are independent events. Then P of E and P of F is defined as P of E multiplied by P of F. We'll take a practice question so that you have more clarity on this concept. What is the probability that a head turns up on a coin? So I have one event P of E as a head coming up on a toss of coin and an even number on a dice. So probability of F is even number on dice when one coin is tossed and one dice is rolled. So it is very clear that tossing a coin will have absolutely no effect on the number that comes on the dice. So simply P of E and F is equal to P of E multiplied by P of F, since these are independent events. So what is P of E? A head coming up on the toss of a coin, that is 1 by 2. Favorable case is head, total number of cases 2, head and tail. Even number coming on a dice, so even numbers are 2, 4 and 6. So I have favorable cases as 3, total number of cases are 6. I can have any number from 1 to 6. So again this is 1 by 2. So what is my answer here? 1 by 2 multiplied by 1 by 2, this is equal to 1 by 4. So remember, P of E and F is equal to P of E into P of F if the events are independent of each other. Let's try another question on this. Ben and Paul are in the same class. The probability of Ben attending a class is 0.6. So I'll just write here P of B, which means Ben attends the class, is 0.6. Similarly, I define P of B bar. It means that Ben does not attend the class. That would be equal to 1 minus 0.6, because he'll either attend or not attend. There are just two cases. So this will come out to be 0.4. The probability of Paul attending a class is 0.5. So I have probability of P, which defines that Paul comes to class, is 0.5. And similarly, probability of P bar, that Paul does not attend the class, is 1 minus 0.5, which is again 0.5. I hope you are clear with why I am subtracting this from 1, because I will have either Ben is going to attend the class, so probability of B, or Ben will not attend the class, so probability of B bar, and both these probabilities will add to 1. That is why I have 1 minus 0.6 for probability of P of B bar. So we have three cases now. What is the probability that both attend the classes? Since Ben coming to class has no effect on Paul coming to class or not coming to class, we have both P of B and P of P as independent events. So both attend the class means P of B and P. So this would be simply P of B multiplied by P of P, which is 0.6 into 0.5, and this is equal to 0.3. So I'll just change the ink color. I just have four cases, that Ben attends the class and Paul attends the class. Ben does not attend the class and Paul attends the class. Ben attends the class and Paul does not attend the class. And the last case, that both of them do not attend the class. We've already found out the answer to the first case, whereas both attend the class, which is B and P, and this is equal to 0.3. Similarly, Ben does not attend and Paul attends, that would be equal to P of B bar and P. So this would be P of B bar multiplied by P of P. This is equal to 0.4 into 0.5, or in other words 0.2. So I have a 0.2 here. Ben attends and Paul does not attend, so this would be simply 0.6 into 0.5, and this is again equal to 0.3. Both of them do not attend the class, so I'll have this here, B bar 0.4 multiplied by P bar 0.5. So this gives me 0.2. If you add all these probabilities, you'll get a total of 1, and which is also true because these are the only four cases possible. There is no other case which is possible. Let's look at the second question here. At least one of them attend the class. So either Paul attends the class, or Ben attends the class, or both of them attend the class, as I have at least one of them attend the class. So I'll just add up these three. I have 0.3 plus 0.2, 0.5 plus 0.3, which is 0.8. So this is the answer to the second question. Also, when we have at least one of them attending the class, as we did in the question of selling tickets, I can find out the probability of 1 minus none of them attend the class. So 1 minus none of them attending the class is 0.2. So 1 minus 0.2, this gives me 0.8. So again the same answer. This is something which we've discussed before also. Let's look at the third part. None of them attend the class. It's clear from here is 0.2. So this entire question was based on just one logic, that B and P are independent events. So the probability is when we multiply both the probabilities. So let's look at the next concept here. Conditional probability. The probability that an event A will occur given that another event B has already occurred is given by P of A intersection B divided by P of B, and it is denoted as P of A slash B. We look at this example for more clarity. What is the probability that the second card drawn after a red card has already been drawn out in the first chance and replaced in the pack will be an ace? So here, what is the event B which has already occurred? It is that a red card has already been drawn out. So what is the probability of event B here, which is probability of getting a red card? We know that there are 26 red cards out of a total of 52. So the probability of getting a red card is 26 by 52. Now P of A is getting an ace. So P of A is what? 4 by 52. We have 4 aces out of a 52 pack cards. So what we need to calculate here is P of A intersection B. So P of A intersection B would be getting an ace and a red card. So how many aces do we have of the red color? We just have 2 aces. One is from the suit of diamonds and the other one from hearts. So I have 2 by 52. Out of the total cards 52, I just have 2 cards which are red as well as aces. So the probability we need to find out here is P of A slash B, which means that B has already occurred. What is the probability that A will occur? So this is P of A intersection B divided by P of B. So what is P of A intersection B? We've calculated 2 by 52. And what is B? P of B? 26 by 52. So I have 26 divided by 52. So what is my answer? 2 by 26 or 1 by 13. So this is what is conditional probability. I hope this is clear. This is the last concept for probability. The number of heads on tossing a coin n times or tossing n coins at once. Both of them mean the same thing. Now listen to this very carefully because this is definitely asked in the exam. Let P be the probability of getting a head. So I know that P here is 1 by 2. And Q the probability of getting a tail. So I have Q also equal to 1 by 2 in the toss of a coin. If a coin is tossed n times or n coins are tossed simultaneously, both of them mean the same thing, then NCR P raised to power R Q raised to power n minus R gives the probability of getting R heads and n minus R tails. We'll do this with an example. For example, a coin is tossed 4 times. So I have n is equal to 4. Find the probability of getting all 4 heads. So here I have R also equal to 4 as I want 4 heads. So n minus R would be 4 minus 4, which is 0. So let's put the value in this formula. I have NCR P raised to power R and q raised to power n minus r. So what is n here? N is 4, r is also 4, so 4c4 into p raised to power r. P is 1 by 2, 1 by 2 raised to power 4 multiplied by 1 by 2 raised to power n minus r. N minus r is 0. So 4c4 is 1, this is also 1. So what is my answer? 1 by 16. Let's take the second case, getting 3 heads and 1 tail. So here also I have n is equal to 4, I have r equal to 3, so I have n minus r is equal to 4 minus 3, which is equal to 1. So now again I'll put this in the formula, n cr p raised to power r q raised to power n minus r. So I have 4c3 multiplied by half, which is p raised to power r. R is 3 multiplied by 1 by 2 raised to power 1. So this gives me 4c3 is 4 multiplied by 1 by 16, and this gives me 1 by 4. Also in this formula you can take p as the probability of success and q as the probability of failure. So p here can be defined as success, as we'll do in the next question, and q as the probability of a failure. Let's try another question on this. Experiment succeeds twice as often as it fails. As I told you in the previous slide, p can be taken as the probability of success. So if it succeeds twice as often as it fails, so p is 2 by 3 and q, this probability of failure, is 1 by 3. What is the probability that in the next 5 trials there would be 4 successes? So I have n equal to 5, r equal to 4, r is the number of successes. So n minus r, which is the number of failures, is 5 minus 4, the number of successes, equal to 1. So again we'll apply the formula NCR, the success probability p raised to power r, and q raised to power n minus r. So n is how much? N is 5, c4, p is 2 by 3 raised to power 4, and q is 1 by 3 raised to power 1. So what is 5c4? This is nothing but 5. 5 into 2 by 3 raised to power 4 multiplied by 1 by 3 raised to power 1. So this C option here is the right option. That is all on concepts of probability. Look at the video number 2 on probability, wherein I'll solve 7-10 odd questions that are generally asked in the examinations, and you'll have more clarity on the concepts.